Hello and welcome to AI for Developers. I'm Chaitanya talking bot. Today's lesson is titled Retrieval Augmented Generation, RAG, making LLMs smarter with your own data. Imagine a super smart digital assistant that can chat, write essays, summarize documents, and even generate code. That's a large language model, LLM. They're like incredibly powerful predictive text systems, trained on vast amounts of internet data. They're amazing, but they have a few limitations. 1. They don't know things that weren't in their training data, e.g., yesterday's news or your company's internal policies. 2. They can sometimes hallucinate confidently, making up facts that aren't true. 3. They don't have access to private or very specific data that's unique to you or your business. As a developer, you might want an LLM to answer questions about your company's latest product specifications, your internal HR policies, or very specific client documents. The problem? Standard LLMs haven't been trained on this proprietary or very niche information. Retraining an LLM is incredibly expensive, time-consuming, and complex, not something an individual developer or small team can easily do. So, how do we give these powerful AI models access to your unique and specific knowledge without breaking the bank or starting from scratch? This is where Retrieval Augmented Generation, or RAG, comes in. Think of RAG as giving your super smart but sometimes forgetful friend, the LLM, a personal, highly efficient librarian. When you ask a question, the librarian, the RAG system, doesn't guess. Instead, it first quickly finds the most relevant information from your own private collection of books, data. Then, it hands that specific information to your friend, the LLM, and says, "Here's the relevant context. Now answer the question based on this." This ensures the LLM's answer is accurate, up to date, and based on your facts. As a developer, this first step is about preparing and searching your data. 1. Your data. You start with your own documents, PDFs, databases, web pages, internal wikis. 2. Breaking it down. These documents are too big to search easily. So, you chunk them into smaller, digestible pieces, like pages from a book or paragraphs. 3. Vector embeddings. Each small chunk of text is then converted into a numerical fingerprint or vector. Think of it as summarizing the meaning of the text into a series of numbers. Pieces of text with similar meanings will have similar numerical fingerprints. 4. Vector database. These numerical fingerprints are stored in a special database called a vector database. It's like a super indexed library catalog that can quickly find all pieces of text whose fingerprints are close to each other. When a user asks a question, the question itself is also turned into a numerical fingerprint, and the vector database quickly finds the most relevant chunks from your data. Now for the LLM part. 1. Augmentation. The most relevant chunks of data, the books our librarian found, are retrieved from the vector database. These retrieved chunks are then added directly into the prompt that's sent to the LLM, along with the user's original question. It's like saying to the LLM, "Here's the user's question, and here are 3 to 5 relevant paragraphs from our internal documentation. Please answer the question using only this information if possible." 2. Generation. The LLM then reads the user's question and the provided context. Instead of just guessing or pulling from its general training, it uses your specific, provided information to formulate a precise, accurate, and relevant answer. From a developer's perspective, you're programmatically creating a rich, contextual prompt for the LLM, dramatically improving its output quality. RAG solves critical problems and opens up new possibilities. Accuracy. It drastically reduces hallucinations because the LLM is guided by factual information you provide. Up-to-date and private data. Asterisk you can easily update your knowledge base with the latest information or integrate confidential company documents without ever retraining the LLM. Cost-effective. Asterisk no need for expensive, time-consuming LLM fine-tuning or retraining for new data. Control and explainability. Asterisk you have a clear audit trail. You can see exactly which pieces of your data were used to generate the LLM's answer. Rapid development. Asterisk quickly build powerful AI applications that leverage specific enterprise knowledge, accelerating your project timelines. As a developer, you'll be connecting several pieces to build a RAG system. Data loaders. Asterisk tools, often libraries, to ingest data from various sources. PDFs, websites, APIs, databases, text splitters. Asterisk to break down large documents into smaller, manageable chunks. Embedding models. Asterisk I models that convert text chunks into those numerical fingerprints. Vectors. Vector databases. Asterisk specialized databases, e.g., Pinecone, Weaviate, ChromaDB, FAISS. Designed for efficient storage and search of these vectors. Orchestration frameworks. Asterisk libraries like LangChain or LlamaIndex provide abstractions and tools to seamlessly connect all these components, from data ingestion and chunking to embedding. Vector search. And finally, querying the LLM with the augmented prompt. You'll write code to define this workflow. RAG allows you to take powerful, general-purpose LLMs and instantly specialize them with your unique and specific knowledge. Imagine customer support bots that know your exact product specifications, internal tools that answer HR policy questions precisely, or research assistants that can summarize specific reports from your internal archives. This isn't just theory. RAG is a practical, powerful pattern that developers are using today to build more intelligent, reliable, and enterprise-ready AI applications. It transforms LLMs from general knowledge machines into expert systems tailored to asterisk your needs. Thanks for watching. If you found this helpful, make sure to subscribe to our channel and hit the like button.